Okay, so in this problem, uh, we've got this thing rolling. There's a pin on it, okay, and it's going within that slot, and it's rolling with a constant angular velocity at 20 radians per second. Um, X is 24, that horizontal distance, when it's 0. So this actually rolls forward a little bit to get to the angle of 30, and I'm trying to figure out, hey, what's the angular velocity of that bar, and what is the relative velocity of that pin, again, relative to that bar here. So the first thing I need to do is a little bit of trigonometry, which is to say, again, recognize that this guy rolls forward a little bit, okay? And how much it rolls forward, because it's rolling without slipping, is essentially, we'll call it delta x equals r times theta, which is going to be, my radius is 10 inches and my theta is pi over 6, which is 30 degrees, right? And that equals 5.24 inches. So that thing rolls forward 5.24 inches, okay? Which means, well, we'll put it up here. At x now becomes 29.2 inches, right? Is how far that's moved forward, okay? Now, the other thing I know is, right, this distance right here, right, that's 7 inches, okay? And then from trigonometry, okay, knowing that I've moved 30 degrees, 7 cosine of 30 is then 6.06 inches high. Again, what I'm doing here is I'm developing a triangle that I can kind of deal with here, okay? And so it's now, because it's rolled 36 inches, it's done that. Whoops. The other side of that triangle is sine is 3.5 essentially, right? Which means the whole distance here, from here all the way to there, is 3.5 plus that 29.2, right? Because again, it's 7 sine 30, this little guy right here. Okay, so the whole thing then is 32.7, right? So there's my triangle right there. Now I can do an inverse tangent, and I can determine that this angle right here is 10.5 degrees. Okay, so hopefully you followed all of that geometry to figure this out, okay? Now, I'm going to go ahead and write my equation that I'm going to be dealing with, which again is going to be the velocity of P equals the velocity of B. Again, this is the connection with the slider in it, plus omega BP, which is what I'm looking for, crossed with R of P relative to B, and then plus the velocity of P relative to B. That's also what I'm looking for, is that relative velocity equation. Now, in the past I said, hey, set this thing up so the x and y axis line up with the slider. Now, because of this rolling without slipping, because that velocity gets very tricky, I think it's actually in the best interest, because the velocity of P will be so difficult to get in the orientation other than the horizontal and vertical that we're looking at. We're just going to stick with the classic, horizontal and vertical for x and y, and hopefully this will become clear as I work on this first quantity, which is the velocity of P, right? Now, again, this is rolling without slipping. I know the angular velocity. What I know when I have rolling without slipping is that this point right down here, which I'll call C, my contact point, has to be 0. So I'm going to relate everything to that, because having something go to 0 makes my life a lot easier. So I'll say the velocity of C plus omega, and this would be, I'll call it omega CP. That's, oops, not CD, CP. That's the omega, that's the 20 radians per second. And I'll cross that with the R of P relative to C, like that. Now, again, what I just talked about is the velocity of C goes to 0. So all I have is this omega cross R value that I'm looking at here, okay? And omega is given to me, okay? I know that omega is negative 20 in the k direction given in the problem statement, and I'm just going to cross that with the r vector. In the x direction, it's just going to be the, again, the 3.5, right? 7 sine 30, that's going to be the 3.5 I moving horizontally. And then vertically, it's going to be 10 plus 6.06, right? So it's going to be 16.06 up in the j direction, right? So again, I move over 3.5, up 16.6. Okay? That cross product then becomes my velocity of point P, which is just going to be negative 70 j plus 321 in the I direction. So that's the velocity of P, again, in the horizontal and vertical directions. This would be pretty challenging then to do, an angle, 10.5 to figure that out. I think it'll be easier to just apply that to the other quantities at this point. So we're going to leave it like that at this point. So that's the velocity of P. Again, the velocity of B is 0 because it's connected at the point there. So now I've got my omega BP, which is what I'm looking for, one of the things I'm looking for, crossed with r of P with respect to B. Now this is where if I'd set up my x-axis, say, along BP, this would just have an I value. Instead, I'm going to have, well, omega BP in the k direction. Again, I don't know its magnitude, but I know it's in the z direction. And that's going to be crossed with the 32.7 in the I direction plus 6.06 in the j direction. Okay, and again, I think this will be a little bit easier than trying to convert that other one to my angled axes. Okay, so from that, I get negative 32.7 omega BP in the j direction plus 6.06 omega BP in the I direction. Okay? Then I have my last term, which is the other thing I'm trying to find, which is the relative velocity of P relative to B. And again, I know its orientation, or its direction. I do not know its magnitude. And again, had I set this up with that angled surface, this would have just been, say, in the I direction. But again, because I didn't want to deal with converting it, we're going to just leave it as it is now. So again, it's going to be sine and cosine of the 10.5 degrees. So that'll be the relative velocity. Cosine 10.5 in the I plus the velocity of P relative to B sine 10.5 in the j direction. Okay, so now I break it up into my x and y axes. So again, VP in the x-axis, 321. That'll be equal a positive 6.06 omega BP. And then plus, that'll be this guy, which is 0.93. That's the cosine of 10.5 is 0.983, velocity of P relative to B. So I do the same thing in the y direction. I get negative 70 in the j direction. And then I get negative 32.7 omega BP. And then I get plus 0.182, the velocity of P relative to B. So two equations, two unknown. Through the magic of algebra, I find that the omega equals 3.82, and that is going to be radians per second. I believe that's actually going to be a negative. okay? And the velocity of that pin joint relative to the rod is going to be 303 inches per second, okay? And those are the answers that I'm looking for. So again, just because that velocity was a little bit more complicated, we left this in the horizontal and vertical. You could have switched it. It just would have made the trigonometry a lot more challenging on that first term that we found.